Well, everyone wants to ensure connectivity is secured. Well, what is IPsec? Now, if you've heard about IPsec, or if you haven't heard about it and you tinkered around with VPNs, well, in this video, we're going to talk exactly about what IPsec is, the different forms of authentication. And we may even have to split this up in a two-parter because I think there's a lot of bits that I want to cover and I don't want to blabber on for, an hour just talking about IPsec functionality. So IPsec is basically a form of secure communication between multiple sites across our environment, right? So we want to allow the transmission of that data. If we've got hosts that are communicating with two different areas of the infrastructure, maybe they're in different geolocations. And as the data sort of traverses across the internet, we want to ensure that things remain confidential. We want to encrypt all the IP packets between the locations that we're exchanging information with and providing authentication through that process. So that's what IPsec is. It provides encryption, it provides authentication, it basically renders the protection of the packets being sent between those two different locations or the multiple locations, and then providing that layer of security across our environment. So it does this by obviously packet signing, so whereby basically every packet from one location is signed to ensure that it isn't replied or hasn't replied to these packets where someone could be snooping on the traffic or intercepting that traffic, right? So they could redirect or masquerade to different locations or act as legitimate sources. So we can do that similar to like IP source guard, where we can protect the packet. So IPsec is and can operate in that nature, right? So basically, at the end of the day, when we talk about IPsec, it's all about integrity and ensuring that packets haven't been tampered with during that transit. So now, what are the functions of IPsec? How does it do what it does, right? So the basics and understanding of IPsec. Well, if we look at the OSI layer, and I'll just quickly write out the OSI layer here. We've got the 7 different forms of the OSI layer. We've got our data link. We've got our physical, we've got our data, our network, session, transport, and then our presentation. Um, Typically, the OSI layer where IPsec operates in is at the network layer, right? So we've got maybe other routing protocols like generic route encapsulation, and it typically operates at the layer 3. So this also depends on the requirements of obviously the company, if we're using multiple VPNs on IPsec. So it's basically the tunnel connection between the two branches and ensuring that all the communications between maybe those two sites, in this case, tunnel 1 and tunnel 2, and we'll talk about the different IKE phases as well. We want to make sure that all the communication that's happening between those two sites is obviously secure in nature. Now, before any packet begins moving or begins its transit to the destination, as it sort of begins moving from one location to another, with IPsec tunnel, a number of protocols have to be put in place before everything has to work well. Now, those protocols, as we start talking about them, are two sort of protocols. Now, we've got one called encryption. You might have heard of encryption, and authentication. Now, with encryption, we've got the encryption, or the encapsulation security payload. I'm going to put encapsulation security payload, and that needs to be one form. And then we've got our authentication, and typically with authentication, we've got our authentication header. So I'm going to say auth header. And these two are quite vital in the whole process, and I'll walk you through basically how it does this. And you may see some vendors call the encapsulation security payload like ESP, and you may see authentication header as AH. Right, that's a H. Okay, so that's that. Now, they're the first two parts. Now we've also got the key exchanges. So we've got key exchange that allows us to basically how IPsec is able to identify the various hosts we're being able to receive the packet. So there are two common methods used for the key exchange and host identification. We've got our, so that's one form, and then we've got our IKE, so Internet Key Exchange. Now, without the Internet Key Exchange, so we've got IKE, obviously there's phase 1 and phase 2, so that's one protocol, and then we've got our ISAKMP. Now that's our internet. I'm not going to write that because it's actually a little bit tongue-tying. So it's the Internet Security Association and Key Management Protocol. That's what ISAKMP is. Now, if it wasn't for these two protocols, Internet Key Exchange and ISAKMP, without both of those things, IPsec wouldn't be able to run. And obviously, other communications wouldn't be able to happen. obviously the different various of hosts being able to establish those communications. Exchanging those keys is basically that vital role on how we're going to communicate, how we're going to obviously identify the host on the other end, how do we prove that it's the right firewall in this case that we're going to be communicating to, right? So usually the key negotiation happens over UDP port. So it's UDP port 500 in many cases, and that's how they begin obviously establishing and flowing traffic through the various locations through IPsec tunnels. Now, for IPsec to achieve its goal to ensure data is confidential and ensuring that data remains, in its trusted and truest form, because we want to prove its validity, its confidentiality, and integrity. It hasn't been altered. It hasn't had any tampering with. Obviously, as it traverses, the internet, right, which is, I don't know, I don't want to call the internet a dangerous place, but it's an unsecured channel. We want to make sure that there is integrity with our packets, nothing gets snooped on, and we can prove its validity, right? So that's what it's all about. Now it relies on the now to do that, the first thing that we need to be mindful of when we talk about IPsec, it does this or relies on the authentication header as the first thing. So the authentication header must be added to those various packets that are being sent. So as we're doing that, the authentication header will use a different bunch of hashing algorithms, such as MD5 or secure hashing algorithm like SHA-256, for example. And it basically ensures that particular part of the header would be able to carry out that reference to the destination, that packet wasn't altered. So let's run through a bit of an example on how, if we're going to be sending the authentication header across these two different hosts. So I'm just going to say example 1 here, and this is going to be our authentication header, and this is how we do it. So I'm just going to change pins as I do this. So if we're basically establishing that authentication between the two different firewalls, it will go something like this. So we've got our IP header here. So this is our IP header. And then we've got our, what's next, our data. I'm just going to put our data connection here or data payload, and that'll carry out TCP traffic or UDP traffic. So this is traditionally like a bit of a packet, right? So we have our IP header information, we have our data segment, part of our packet information. What would happen here is the actual router, or in this case, the firewall itself will intercept the packet to basically look like this. So that's the original form, and then the altered form will look something like this, and it will have the IP header. And then we'll have its authentication header. And then finally, you'll have the data. That'll be your TCP traffic, etc. So typically, as we do this, this is where the additional packet authentication header information is added. The entire payload of the packet will be hashed, and whilst the hash value is being calculated, transported over to the other end. So that's how it kind of transition and alters and changes its information. Now, once the packets have been sent, the hash will then be reevaluated and would be verified. Obviously, do they match, right? So like our hashing algorithm, do the hashes match? Do they not match? And then we know that that data has integrity and confidentiality, that obviously nothing has been snooped on. Now, that's our authentication header. So that's one bit of the form of requirements that we need to have. Now, the other part is our encryption. Now, for encryption to happen successfully, this is how it kind of plays out. So let's go through how uh, the our ESP payload down here, when we talk about our encapsulation security payload, this is how this 10 would works out, right? So ESP comes out with a bunch of features as it begins processing of basically that encrypted packets, right? So it uses both the hashing of those packets as well as the encryption. So where the encapsulation payload may use SHA, it may use 256 or 512 of that hashing algorithm. It's padded, and after the hashing takes place, it'll go through and encrypt, and then we can have, so we'll have hashing algorithm, and then we'll have its encryption. So SHA, secure hashing algorithm, can use 256, 512, whatever its flavor, and then its encryption, probably use AES, right? And then 256 or 128. Now, I think I may break this out into another video where I'll talk more around the IKE phases as well. This is just more around how the packets get encapsulated, how they're routed, and then we'll talk more around IKE phase 1, how it goes through its authentication process, and then we'll talk about IKE phase 2 and how the actual user data goes through that phase of the tunnel. So Let's continue on. So we've got the two foundations here. After obviously the hashing and the encryption gets added, now it adds a few things to the payload, such as the header, the trailer. It's got the ICV check, so the integrity check value as well, which gets added, obviously to validate that that data hasn't been tampered with. So here's how we will traditionally break this. So if we take the original header, like let's just take the original packet here. So we've got something like the IP header, got our data here, okay, and then we've got our IP header there. So this is the OG packet. Now, as that packet gets routed, here's how the new payload will look like, or the new packet will look like with the encryption also added. So we've got our IP header. So I'm going to keep that here. Next, we'll have our ESP header gets added. I'm going to say ESPH for ESP header, which gets added to that component. Then I've got the actual bit of data, which gets added. And then after the data is our ESP trailer. So you kind of see how it sort of mushes in the actual, just put that out, ESP trailer, T for short. And then we're going to have finally our ICV, which is obviously our integrity check, right? So our ICV, almost forgot what it means, right? ICV is basically the integrity check. So integrity check value, ICV. And then from that point on, that's our payload, right? So not all packets are basically encrypted as we're talking about, right? So the only packets that get encrypted is just the data payload and the ESP trailer are encrypted. So the data and the ESP trailer, they're the two payloads or two bits of the packet function here that get encrypted. Now the IP header, the ESP header, and the ICV all remain unencrypted. And when it comes to the authentication part, the authentication phase, only the ESP header, the data, and the trailer have all been basically authenticated. So the ESP header get authenticated, the data of course gets authenticated, and the ESP and finally, obviously, the ESP trailer obviously gets its authentication as well. So they're the three different forms when it comes to authentication, obviously the encryption, and that's how IP functions to secure the communications across the internet. So that's just kind of an overview. In the next video, we'll run through the IC phases as well, and you get a bit more understanding on how that works. I hope you've enjoyed this video. If there's anything else you'd like to see for me to explain around IPsec, please let me know in the comments. Hope you've enjoyed this video. See you all in the next video. Bye for now.